Good morning, guys. This is Anjani Kumar, Electrical Department, Newton's Group of Institutions. So I'm continuing my lecture on basic electrical machines, how they are working. So till now, I discussed about DC machines, how the generator will work, how the motor working, all these things we'll discussed. Today we'll discuss about AC machines. So basically AC machines are classified into two types. The first one is induction machines, second one is a synchronous machine. These two categories we'll discuss in entire electrical subjects. So what is induction machines? The name itself indicates the process of induction. So mutually induced, you know about the definition of mutually induced EMF, how one flux links with another flux, generating EMF, another conductor. This is nothing but the same process will come here, right? So induction machines, the mode of operations, induction machines are classified into two types. The first one is induction generator and the second one is induction motor. So what is induction generator? So induction generator which converts mechanical energy into electrical energy. So with the speed of a rotor which is greater than the synchronous speed, we can call it as an induction generator. Just think it out. We'll discuss later what is a synchronous speed, what is a rotor speed, we'll discuss. So in an induction generator, the speed of a rotor, NR, is greater than the speed of a stator. That is nothing but synchronous speed. Right? So NR greater than NS, we can call it as an induction generator. Very, very important questions. So what is induction motor? So induction motor which converts electrical energy into mechanical energy with the speed of a stator, that is nothing but synchronous speed, NS, which is greater than the rotor speed, NS greater than NR. So we can call it as an induction motor. These two are very, very important short answer questions. But what is a synchronous speed? The speed of a rotating magnetic field, we can call it as a synchronous speed. We'll discuss what is rotating magnetic field, how the field starts rotated. I said earlier, if you rotate a conductor, we can call it as a DC machine. If you rotate a magnet, that is nothing but if you rotate a field, we can call it as a AC machine. Here, we are rotating the field. How the field is rotated, we'll discuss. Right? So induction motor. So first we'll start induction motor. So each and every AC machine there has two parts. First one is a stator and the second one is a rotor. Stator which is having a stationary part and which is having stationary windings, stator windings. A rotor which is having a rotating parts and inserted with rotating rotor windings. Right? Induction motor in a stator which is having a poles, in a rotor which is having conductors. So based on rotor construction, induction motor further classified into two types: squirrel cage rotor and slip ring rotor. That's why we can call it as a squirrel cage induction motor, slip ring induction motor. Alright. So what is a squirrel cage rotor? The construction is look like a rotor which is having a copper bars itself. It doesn't have any rotor windings. So the copper bars will act as a rotor windings. That is the difference. In slip ring induction motor, which is having a copper bars also, and which is constructed, whatever the stator winding, start phase is there, three-phase AC supply which is connected in a star type. In a rotor also, conductors are which are connected like a star connection. Rotor windings are connected like a star connection, which are ended up with a slip rings. So what is the use of a slip rings? That's why we can call it as a slip ring induction motor. So what is the purpose of slip rings? Slip rings are inserted with connected with a resistance. So when a resistance are going to be added, if any further increases rotor current will exist, definitely the resistance will be cools down the current. reduces the current level in the rotor, so without affecting the damaging of a rotor. And also it injects the voltages in order to reduce the speed of induction motor. Right? These two are brief introductions. So induction motor, which is having, depends upon the rotor construction. The induction motors are classified into two types: squirrel cage induction motor, slip ring induction motor. Right? What is the purpose of slip rings? Means it reduces the current by adding inserting resistances. It will inject the voltages also, because in induction motor speed will be depends upon the square of the voltage. That's why with the help of voltages, we can reduce the speed also, right? And coming to the construction, induction motors are asynchronous motor. It's not a synchronous motor. We'll discuss now operations. We'll get why we can call it as a synchronous motor, why can't synchronous. We'll discuss. Alright. And now we'll come to the operation of induction motor. It is very, very important. So I said earlier, induction motor, which is having a stator and the rotor. Stator having a poles, right? So induction motor, which converts electrical energy into mechanical. So we'll give the AC supply, we need to rotate. That's it. So basically 90% of energy consumption in this world through induction motors itself. Right? That's what that much advantages that we have, because very well less cost and economical considerations. We'll discuss variable speed also we'll get. So we'll discuss first the operation, and after we'll discuss about advantages and all these things. Stator and the rotor. So now 3-phase AC supply is given to the stator. In a stator, I'm having a poles. When 3-phase AC supply is given to the poles gets excited, right? The flux will be developed, and how the flux will be travel in a stator. So that is a rotating magnetic field. How it will be happened in the stator. See, 3-phase AC supply is given to the stator. How it will happen, you will see.